Hi, this is Dinesh Kumar. This is my solution for Spark Streaming Innovation Contest. So initially I've been given two data sets, training data set and a prediction data set. And things I have to do is filter the bad data and enrich the data using HBase, find a cumulative count of anomalies, and trigger a general alert for every anomaly, trigger a critical alert if there are more than 20 anomalies in a minute, and persist the entire record into Elasticsearch, persist all the anomalies into RabbitMQ, and create a visualization dashboard for every cumulative count. So in order to create an anomaly system, first we have to know the number of clusters our data belongs to, and what is the threshold that you have to have in order to say a record is an anomaly. So in order to find the number of the k, I had two algorithms. I had two methods. One is the elbow method, and the second one is using the minimum mean of the distance of all the records from the centroid. So using elbow method, I couldn't get a perfect elbow in this data set, but there was a little bit changed when I changed the cluster size from 5 to 6 to 7. So I chose 6 as my cluster size. I believe there are 6 different events within the data set, and within that I made a histogram of 20 different groups so that I can spread the groups of data which falls under different distances. And some of the values that I got for each group, the group 1 had 18,388 and group 2 had 1112 and group 3 had 370. So I believe all the first 3 groups will be a normal data. It's not an anomaly. So whatever comes after the third group is anomaly. So I chose the histogram which starts with the third group, which is 7.32 as my threshold using elbow method. But when I tried with the second method, which is using the mean of all the distances within the centroid, my cluster size is going more than 100 to get the minimum mean, which doesn't sound correct, because that cannot be 100 different events within the data set. So I'm going with elbow method. Here is my solution for the problem. So first I'm filtering with the bad data, which is removing the zeros and 1, and then in streaming k-means I'm giving the value which I obtained from the model, which is 7.32, and in variable type I am actually including all the variables. The reason I'm including all the variables is so we don't have the business background within the dataset. We don't know what is flag A0, what is flag SF, what should be actually treated as an anomaly. We are exactly going with what the model says. So it's better to have all the data, all the records, all the columns within that, because even to find the threshold we used all the columns. Although I used all the columns, I used OR scaret package to actually define the variable importance, what variable makes actually these cluster. So I found these two variables, root shell and land, to have negative importance, which is not helping the model as much. But still I cannot remove this from the data set, from the configuration, because even a change in those two can lead to an anomaly. And once the anomaly is detection, whether it is true or false, then I enrich the data using the lookup function provided in one of the article, and then every data is persisted into the Elasticsearch, both the anomalies and the normal data. And then I have a filter condition which will just take the anomaly and give a general alert for every anomaly, and then each anomaly is again persisted into RabbitMQ. Once it is persisted into RabbitMQ, we create another system, window based system, for every minute. So records within every minute are counted using cumulative aggregation processor, and we add a timestamp to that, and then we have a flat map to, because the output from the cumulative aggregation is key value, but we need to work on a value parameter. We have a flat map, and then the output goes to both streaming as well as filter. We want the streaming in order to create a dashboard of all the cumulative counts. At the same time, we want alert if the anomaly is greater than 20. So filter is to just check if the anomaly is greater than 20, and then it gives a critical alert. So if we see the dashboard, so this is how the dashboard looks. We have anomaly counts of 186 for every minute, which is more than 20. So almost for every minute we are having a critical alert. That's it. This is my solution. Thank you.